Okay, the next problem we're going to do is problem number 8. And it says, by what factor will the pressure of a sample gas change if the volume is reduced by 1/3 while the Kelvin temperature is doubled? Now, one of the ways that I like to tackle this is I like to just use my equations that I know, right? So I have this equation, T1. We're going to assume again that n is equal to 1 because we're not seeing n mentioned anywhere. And then I'm going to plug some numbers in based on what it said. All right? So it said the volume is reduced by 1/3 from one state to another from when I go to here to here. So I'm going to put V is going to be 1 liter. And then I'm just going to put V2 is 0.33 liters. That's 1/3. And then it says that my temperature is doubled. So I'm just going to put in 2 temperatures. And now I can compare P1 and P2. And basically what happens is I get P1 times 0.01 is equal to P2 times 0.00165, or P2 is equal to 6 times P1. So that means that P2 is 6 times P1. I can just take this and divide both sides by 0.00165, 0.00165, and that is what I get. All right, so the next problem I think is the hardest one of the whole thing. It's a combination sort of Dalton's and ideal gas laws. So it says, what is the final pressure of the container shown below after the valve is opened and the gases are allowed to flow? So basically you have nitrogen in this container in state 1, and you have oxygen in this container, it's state 1. And then when I open all of this up, that is state 2. So individually, state 1, and then they're each going to go to this new total volume and this new state 2. And it wants to know what is the final pressure in the container, which basically is P2. So this is P1, V1 for nitrogen, and this is P1 and V1 for oxygen. I'm going to have this new volume, which is basically the 2 added together. So my V2 is equal to 5, and I'm going to solve for P2. So let's do that. So the way I'm going to do this is I'm going to set up 2 separate equations. I've got nitrogen, right? P1 is equal to 2. V1 is equal to 2 liters. Okay. And then V2 is equal to 5 liters. So I plug all that in. My P1 V1 equals P2 V2. And I get 2.0 atmospheres times 2.00 liters is equal, this is the new P2 that I'm trying to calculate, times 5.00 liters. P2 for nitrogen is equal to, let's see, I get 0.8 atmospheres. I'm going to do the same thing for O2. I've got 4 atmospheres times 3 liters, that's its conditions, that's P1 and V1. P2 times 5 liters. P2O2 is equal to 4.2 atmospheres. So P total is going to be 0.8 atmospheres plus 3.4 atmospheres, and that is equal to, 2.4 atmospheres, and that is equal to 3.2 atmospheres.